Hey guys, I'm Aslak and this will be your Friday video. Today I don't have too much time, so I'm just gonna shoot here in my living room because the light was so nice. And today I'll be talking about Schrödinger's cat, which is my favorite thought experiment. But to be able to explain to you properly the Schrödinger's cat, which is probably a topic you've all heard about at least, I'll need to explain a little bit about quantum physics. Now, I won't explain quantum physics, because quantum physics is probably the most complicated topic within physics at the moment. And, well, frankly, no one really understands quantum physics. I certainly don't. But I'll try and pass on what I know to you guys. Basically, quantum physics is the physics of small stuff. When we think of the laws of physics, we think that they were continuously on all the scales of size, from astrophysics to quantum physics. Quantum physics is the subatomic and atomic particle level of physics. Basically, the first and most defining feature of quantum physics, or quantum theory, is what is called Heisenberg's uncertainty principle. It goes something along the lines of, you can't simultaneously know where something is and how fast it's moving. Okay, so now I'll try to explain that, what I mean about that. Basically, imagine you're in a completely dark room. There's nothing, you can see there's no light. In your hand you have a flashlight, and you know there is a baseball somewhere in the room. To find the position of this baseball, you'll need to shine your light on it. So you'll turn off on the flashlight and you'll shine your light on the baseball. That's basically how we figure out the position of quantum particles or subatomic particles as well. We shine small laser lights and we see the reflection of them. So in baseball size, this wouldn't really matter. Now scale this down to quantum level and think of the baseball as a particle instead. Here things change a little bit. Now we can either throw photons, light, really fast at the particle to try and determine how quickly it's moving, or we can throw really precisely to try to determine where it's standing or what position it has. Now the problem is, if you throw the light really precisely, it's incredibly difficult to exactly determine how much energy goes into this, and therefore how much is transferred to the particle, therefore what momentum it has. And if we throw the light really fast, we'll end up not really knowing where we hit the particle, meaning not knowing its position. So that's basically the most defining thing about quantum theory. There's a lot more to go into it, and you can read it up on the web. There's some really good threads in in your pants right now in the science and technology sections. Now, Schrödinger's cat. As I mentioned, Schrödinger's cat is a thought experiment. I have to stress this point. Schrödinger's cat is a thought experiment. Basically, the cat in the experiment is meant to be thought as a representation of a particle. It's a small, tiny particle on the quantum level. It's not a real cat. We could do this with particles, but cats are cuter, so we'll do cats instead. There we go. The battery failed. So, the experiment goes something like this. There's a cat in a box. Remember, the cat represents a particle, and this is all on the quantum level. Also in the box is a few particles of a radioactive material, a Geiger counter, a small hammer, and a glass cylinder of hydrogen cyanide. Now, the box is designed so that no message can be sent in or out, effectively removing all observers from the experiment. The radioactive materials work this way. When they decay, they release radiation. This radiation is picked up by the Geiger counter that sends a signal to the hammer to crush the hydrogen cyanide. Hydrogen cyanide is a very dangerous poison which will most definitely kill the cat, which is of course the clue in this project. So what's so special about this experiment? Well, the whole idea with there not being any observer puts the cat into what's called a superstate. What's a superstate? Well, superstate is a theory within quantum physics that explains the phenomena that something that does not have an observer can be in two states or two positions at one time. Most common example of this is light being both waves and particle, as in the double slit experiment, which I might talk about some other time. So, this cat is in a superstate between dead and alive, because we cannot know whether the radioactive material has decayed yet or not. There's no way of predicting this. And when that decays, it sends a signal to the Geiger counter releases the poison, and the cat dies. So the second we close the box, we have no idea whether it's dead or alive anymore. And then it's in what we call a superstate, being both dead and alive at the same time. Now this is a really weird thing to think about if you're talking about a cat. So remember, we're talking about quantum level physics here. This is a small tiny particle, most commonly applied to electrons being in two positions at one time. So what quantum mechanics say here though is that stop worrying your little head on whether the cat is alive or dead. Just assume it's 50-50 and go from there. So that's how quantum physics work. You do maths with uncertainties basically. You just calculate it as if both things were true, and somehow the math works out, which is the weird, fantastic point about it, and also what makes it so incredibly complicated. So that was basically what I'm gonna say about quantum physics and Schrödinger's cat right now. If you have any questions, leave them in comments. I'll take it up either in the comments myself or as in the next episode. So, apropos next episode, what I'll be doing is next time I'll be posting the double episode I was promising you, where I'll talk about what I was doing in New York and why I was there, and I'll also be showing you some physics things I found on the way and while I was there. And Alex, about your challenge, one thing I tried to focus on doing when I was in the US was being simply polite to service personnel. As I've been told by many of my American friends, it really stinks being a waiter in the US, so I always try to tip handsomely and be polite to such people as waiters and police officers. Oh, and security officers. You've no idea how many security officers you meet when you walk into the UN.